Okay, remember that on your notebooks, you guys, I will be checking for notes, so make sure you take them.
Do we get points?
Yep.
Do you have these up on Moodle as well, or no?
Yeah, I will.
No?
Mm-hmm. Okay.
How often will you do notebook?
About every 3 weeks, I'll do a notebook check. Okay? All right, so today we're still continuing on section 2-1. And today we want to talk about some definitions. Major one today is called cardinality. We're not talking about the bird, cardinals. Okay? But cardinality is where you look at the number of elements in a set. So it's the number of distinct elements in a set. And when I say distinct, I mean there's no repeats. So if you see something repeated, you don't count it twice or however many times it's repeated. You only count it once. Okay? An example of that would be for this set right here. And the notation for cardinality looks like this, in parenthesis A. Okay? So the cardinality of A is what? 3. Yep. Okay? What if I looked at B and I have this? What's the cardinality of B? It's also 3. And we're not counting the number 1 twice. Okay? So this is also 3. How about C? What if I have this? What's the cardinality of C?
0.
0. Very good. Yeah. Just because it's an empty set, we're counting how many elements are in the set, and we can honestly say there's 0 elements in the set, right? For C.
Wait, what's the? Alright, is that the same? C? Is that the same one? C equals diagonal?
Yeah. This goes with this one. Yep. Any questions? Yeah. Yep. How many elements specifically? If I said the set is Sam, Joe, and Shannon. What's the cardinality of this set? 3. Okay? So even though it's a name, that's still an element, right? Okay. Let's go on. Okay, now I want to talk about equivalent sets. Okay? An equivalent set, 2 sets are equivalent if they have the same cardinal number. Okay? So 2 sets are equivalent if they have the same cardinality. Okay? So, they're the same. They are equivalent if they have the same number of elements. It's another way of putting it. For instance, I have set A, which is 2, 4, 6. And I have set B, which is 1, 3, and 5. Do both these sets have the same cardinality?
Yeah.
Yep. So they are equivalent sets. That is not to be confused with equal sets. They are not equal because they don't have the same exact elements. But they're equivalent because they have the same cardinality. Okay? Also with equivalent sets, there's something called one-to-one correspondence. Equivalent sets always have one-to-one correspondence because they have the same number of elements. So in this one, A and B, if I were to look at these, I can just pair up 2 and 1, 4 and 3, and 6 and 5. Okay? So when we say they have a one-to-one correspondence, that means an element from one set can only be paired with one element from the second set. With one element from the second set.
They don't have to be the same.
They don't have to be the same, no, but they can only be paired up once. Okay? Equality of sets. Okay? Sets are equal when they have the exact same elements. Yes?
Does the order matter?
Order doesn't matter. Okay? Good question. So sets are equal when they have the exact same elements. Okay, another question you might want to ask is, what if one set has 2 number ones and the other set has only 1 number one?
They're not equal.
They're still equal because you don't count repeated values. Okay?
Do we write that or no?
Yep. So this is even true with repeated values. Okay, so I'm going to give you guys some examples in just a minute, as soon as you get this written down. So, here's some examples. On the first one, we have set A, which is 2, 3, 4, and 5. And set B is 2, 4, 5, and 6. Are these equivalent or equal? They're equivalent. They're not equal because one set does not have a 6 and the other set does not have a 3. They have to have the exact same elements to be equal. How about J and T? J has Jeff and Jen in it. T has Tess and Tom in it. Are these equivalent sets or equal sets? Equivalent. Good. Same number of elements. W and K. W is an empty bracket and K is an empty set. They're equal sets, right. They're both empty sets. Yes?
Would something that's equal also be equivalent?
Yes. Good point. So, if it's an equal set, do they have the same exact number of elements? Yes. So then you could say they're both equivalent and equal. Yes?
The equality,
Uh-huh.
is that you just said that the sets are equal when they have the exact same elements, and the other one's just the cardinality.
Right. Yeah. One is just counting the number of elements. That's equivalent. Equality, they have to have the exact same elements. Okay? Look at M and N. We have 19, 19, and 19, and then 19.
Equivalent.
They are,
No, they're equal.
they're both, right? You're not counting repeats. Okay? Okay, A is equal to Mr. Bolstead, and E has Mrs. Johnson in it. So are these equivalent?
Equivalent.
Yeah, equivalent.
Why are they equivalent?
Because they only each have one element.
Yep, they each have only one element. We're counting the number of elements in
If
it.
was, Mr. Bolstead,
Here we
Mr.
go.
Bolstead.
Then it would be equal.
Then it, yep,
Oh.
right.
Jack.
Wait, so the 1999 is kind of this equivalent and equal?
Yep, because you're not counting repeats, and they both have the exact same elements in it. Okay? Yes?
Why are you recording this?
Because I'm going to put it on the Moodle for those that are absent. Okay? And I have 4 classes of this, so.
Hello.
Woo, where'd it go?
Just if you're absent,
Huh?
or can you go back and look at it?
It'll be on the Moodle. Hello, stop. Okay, so look at P and Q. P is an element of X such that X is a member of the natural numbers. Q is a set of 2, 4, 6, and then it goes on forever. Okay, are these equivalent sets or equal sets? Equivalent. They're not equal. How come?
Because they include odd numbers.
Okay, yes. So like if Q had 1, 3, 5 included and so on, then they would be equal. But unfortunately it doesn't, so they're not. So the only thing that's true about this is they're equivalent. They have the same number. However, tell me, what's the cardinality of this set?
2.
It goes on and on and on. It's infinite.
It's infinity. So this is an example of an infinite set.
It's not equal. It's not.
Okay? It goes on forever. What is a finite set? It has a stopping point. So it will give you an actual number for the cardinality. Do you guys know how to write the symbol infinite?
Sideways 8.
Sideways 8. Yep. So
Wait,
it's,
so how do you know, like, what did you say about the 135? If P and Q?
okay, so P in Q it's 1, 3, 5, right? Because those are natural numbers.
How's that natural 0?
Nope, natural numbers is any number greater than 0. That's a whole number.
So no, that's
So 2's not a whole number?
2 is a whole number, but it doesn't have the odd numbers in there too.
Oh, so if there's 1, 2, 3, 4, 5, and then it'd be equal?
Yeah, then they would be equal if it had all the numbers in it. Okay?